Hi everyone, we are currently in week 4 of distance learning. And last week we learned about angle relationships in parallel lines. So this PDF in front of me right here has been posted to Microsoft Teams. This includes your definitions of all angle relationships, corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and same side exterior angles. So you'll recall from last week's learning that corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. When we have corresponding angles, that pair is congruent. Same with these other two. With same side interior angles and same side exterior angles, those pairs of angles are supplementary. So that means that they add up to 180 degrees. Now, y'all have shown me that you know how to identify angle relationships. So in this video, I'm going to show you some examples of how to use your knowledge of angle relationships to find missing information in parallel lines cut by a transversal. First, we're going to start up here with number 1. We are given two pieces of information here. We know that this angle is x plus 12 degrees. We don't know what x is. It's a variable. Variables are unknown numbers. We also know that this angle is 66 degrees. Well, I can identify that these two angles are corresponding angles. That's because they're located in the same location on the parallel lines. Corresponding angles are always congruent, and that means that our one angle is going to be equal to the other angle. So we can figure out the information that we need to know, the missing information, by setting these two values equal to each other. So x plus 12 degrees is going to need to be the same as its corresponding angle, which is 66 degrees. Now, we know how to solve equations. We want to solve for x, so we're going to subtract the constant from both sides. 12 minus 12 is 0, and we're left with x equals 66 minus 12 is 54 degrees. We can check that this answer is correct by substituting it back into the original information. So we know that x plus 12 degrees equals 66 degrees. When I substitute this for x, I have 54 plus 12 equals 66 degrees. 54 plus 12 is 66, so 66 degrees equals 66 degrees. Yes, that is true. So I know x is 54 degrees. All right, let's look at number 2. Number 2 is another example of corresponding angles. They are located in the same location on the parallel lines. And because they're corresponding angles, they're going to be congruent, just like with number 1. So we can set this up. We can say that x plus 55 degrees is going to be equivalent to 2x minus 15 degrees. I'm going to move my variable term first. I want to isolate the variable on one side of the equation. So I'm going to subtract x from both sides. I have 55 equals 2x minus 1x is 1x minus 15. Now I need to completely isolate this variable by getting rid of my constant. So I'm going to add 15 to both sides. And I ran out of room down here at the bottom of my page, so I'll go over here. 55 plus 15, let's see, 55 plus 5 is 60, plus 10 is 70. So 70 equals x, and I'm going to make sure I'm indicating that 70 degrees. And then let's just double check. We can make sure this is correct by substituting this information into each of our original given angles. So if this is true, then 70 plus 55, well, that equals 125 degrees. And we have 2 times 70 minus 15. 2 times 70 is 140. Minus 15 is 125 degrees. And these are supposed to be equal. 125 degrees equals 125 degrees. That's true. So x is 70 degrees. So number 1 and 2 here are examples of corresponding angles, and we know corresponding angles are always congruent. So we can set them equal to each other in order to solve. Okay, now we're going to look at another example of corresponding angles. It's a little bit more complex than number 1 and number 2. I guess it's similar to number 2 actually. So again, these are corresponding because they are located in the same location on the parallel lines, right here, right here. And that means that the angles are going to be equivalent. They're going to be congruent to each other. They're the same measure. So 4x plus 7 degrees will be the same thing as 5x minus 13 degrees. I am going to get all of my variable terms on one side. I'm just solving an equation now like we've learned how to do in school. 5x minus 4x is 1x. And now I want to isolate my variables, so I'm going to add the constant 13 to both sides. 7 plus 13 is 20, so x must be 20 degrees. And we can double check again. 4 times 20 plus 7. 4 times 20 is 80 plus 7, that's 87 degrees. And then for this angle, we have 5 times 20 minus 13. 5 times 20 is 100, minus 13 is also 87 degrees. And since 87 degrees equals 87 degrees, that tells me these are both congruent. They're both 87 degrees. So x is 20 degrees. All right, number 4, we have 2 parallel lines. We see they're parallel because these little arrows on them, right? And they're cut by a transversal, but they're actually cut by 2 transversals. So we want to look at the information on each transversal. So first we have that n is corresponding with 158 degrees. Well, that means then that angle n is 158 degrees. And then we see that this other angle, angle m, well, it's a corresponding angle with the one down here because they're in the same location. So angle M is 18 degrees. This one looked a lot more challenging at first, but look at that. Not much work to do to solve it. Okay, so corresponding angles are always congruent. Now we're going to look at 2 other examples that are not corresponding angles. So we need to identify these first. Let's look at number 5. So here we have angles that are in between the parallel lines on opposite sides of the transversal. This means that they are alternate interior angles. And we know that alternate interior angles are always congruent. So just like what we did with corresponding angles, we can set these 2 angles equal to each other in order to solve for our variable to find that missing information because they're congruent. So we can say that 5x minus 5 will be equal to 3x plus 15. And now we just have a equation that we're going to solve. I subtract 3x from both sides. Remember, when you're solving an equation, whatever you do to one side, you have to do to the other. 5x minus 3x is 2x. Now I want to isolate the variable terms, so I'm going to add 5 to both sides. And I get 2x equals 20. And I'm kind of running out of room, so I'm going to go over here. Well, if 2x equals 20, then I can divide by 2 and figure out that x equals 10. All right, and let's see, 5 times 10 is 50. So let's double check right here, I guess. 5 times 10 minus 5 equals 50 minus 5, which is 45 degrees. And then with our other angle, we have 3 times 10 plus 15, so that's 30 plus 15, which is 45 degrees. they're equivalent, they're equal, they're congruent. So this is true, x is 10 degrees. All right, down here on the bottom, similar but a little bit different. We are on the outside of the parallel lines. That means it's going to be an exterior relationship. And they are on alternate sides of the transversal. So this is an alternate, these rather are alternate exterior angles. Remember, when we're talking about these kinds of angles, it's always a pair of angles because it's a relationship, and a relationship includes two things. You can't have a relationship if you only have one thing. So together, these are alternate exterior angles. And we know that alternate exterior angles are congruent, just like corresponding angles and alternate interior angles. So we can set them equal to each other. 12x plus 7 is going to be the same measure as 5x plus 21. I'm going to subtract 5x from both sides. 12x minus 5x is 7x. Bring down my constant. All right, now I want to isolate my variable term, isolate the 7x, so I'm going to subtract 7 from both sides. 7x equals 14. All right, and if 7x equals 14, I divide by 7, x is 2. All right, so let's double check that this is true. Well, 12 times 2 plus 7, 12 times 2 is 24, plus 7 is 31 degrees. And 5 times 2 plus 21, 5 times 2 is 10, plus 21 is also 31 degrees. 31 degrees is the same as 31 degrees. So this is true, x is 2 degrees. Okay, I have two more problems that I want to do for you. And these are going to be the last ones that are on your definitions list. So let's look at number 7. Now you'll notice that we have same side interior angles. Why are these interior angles? Because they are in between the parallel lines. And why are they on the same side? Well, they're on the same side of the transversal. They're not on opposite sides like alternate. So what we know about same side angles is that they are supplementary. And supplementary means that when we add the angles together, they add up to 180 degrees. They have a sum of 180 degrees. So how can that help us solve for our missing information? Well, we know they're supplementary. We know when we add them together, it should be 180 degrees. So we can do 3y minus 2 plus the other angle, plus 68, and that should be equal to 180 degrees because they're supplementary, and that's because of the kind of angles they are. We can remove our parentheses because we're not distributing anything. I mean, there's a 1 here, but anything times 1 is itself. Okay, then we need to combine our like terms. We have a negative 2 and we have positive 68. So you could think of that as 68 minus 2, which is 66. All right, now we need to get our 3y by itself. So we subtract our constant. We have 3y equals, let's see, 180 minus 66 is 114. And then we want to solve for y by dividing by 3. All right, and 114 divided by 3, y equals 38 degrees. All right, we can double check this again by substituting it back into our original diagram. 3 times 38 minus 2, let's see, 3 times 30 is 90, and then 3 times 8, did I do this right? Yeah, 3 times 30 is 90, 3 times 8 is 24. Oh yeah, I see what I'm doing, okay. So 90 plus 24 is 114. Minus 2 is 112 degrees. Now, in previous ones, we would say, okay, well, 112 is not equal to 68, so maybe I messed up. But that's because in our previous examples, we were doing congruent relationships. Well, here it's supplementary. So when we get to 112 degrees, we need to check, is 112 plus 68 equal to 180 since it's supplementary? 112, let's see, plus 8 would be 120 plus 60. Yes, 180 degrees. So y is 38 degrees. Okay, and then finally, our last one that I want to do, we have same side exterior angles. We know they're on the same side because they are on the same side of the transversal, but they are exterior angles. Oh, I didn't put interior up here. These ones were interior at the top for number 7. Same side exterior angles are also supplementary. So again, that means that when we add the angles together, they're going to have a sum of 180 degrees. So 3x plus 10 plus 5x plus 90 will equal 180 degrees. We can remove our parentheses because everything has already been distributed. So 3x plus 5x is 8x. 10 plus 90 is 100. So I really just combined like terms there. And then we want to get our variable by itself. So we have 8x equals 80. All right, and then to solve for x, we can divide both sides by the coefficient, by 8. Get x equals 10 degrees. And again, we can check. Let's see, 3 times 10 is 30. 30 plus 10 is 40 degrees. And then 5 times 10 is 50. 50 plus 90 is 140 degrees. And 40 plus 140 does equal 180 degrees. So we know that x is equal to 10 degrees. Okay guys, so these are some really great examples of how you can use your knowledge of angle relationships to find missing angles, to find missing information, variables that might be written in your angles. And if you have any questions, just message me on Teams or join me during office hours from 2 to 3 p.m. every school day. I hope you guys are doing well. Remember to always make the rest of your day the best of your day. Love you. Bye.